طيب بسم الله الرحمن الرحيم. Addressing, of course, طبعا احنا المفروض يعني we're supposed to be masters in this part. So addressing here is IP version 4. Of course, supports the concept of subnetting. So why do we need subnetting? Why do we need subnets?
So to make smaller networks,
yes.
make them contact with each other faster. So you don't have to go to router every time.
لا الجزء الثاني صح الجزء الثاني غلط.
The routing table summarize multiple routes to fewer.
لا not exactly for routing table.
Maybe management security.
Management security. Elaborate.
Yeah, management and security.
أيوة elaborate يعني.
So, for example, if you have multiple, if you have one network that is for employees and students and so on, a lot of problems can happen. A lot of communication, congestion, and so on. Yeah, so maybe if you can divide it into multiple subnets, smaller subnets. You're
getting there. It's about isolation. It's about network isolation. So you want to isolate networks from each other, because if you put a switch, then technically all this is one LAN, which means one subnet, which means all these have physical connectivity with each other. Okay? Router provides logical connectivity which can be controlled. Okay? Router provides logical connectivity, not physical. Physical معناها you don't have control. خلاص, things are physically connected to each other. That's what the switch does. Router provides logical connectivity that can be controlled. For example, I can isolate a network from being able to communicate with another network. Never, okay? I can do that. Just to put this in the forwarding table, and now these two networks, they can never communicate with each other. I can do whatever I want, okay? So logical connectivity I can provide. No?
So I guess there is also that VTL, I guess it's
that
something called VTL, if I remember correctly, for
قصدك virtual LANs?
Yes.
Virtual LANs, yes. Virtual LANs is a concept that provides the network isolation or the in on top of the data link layer. Okay, so it provides the same thing but within the switch. Okay, so it actually breaks down the physical connectivity into, again, logical or virtual connectivity that can be controlled by the switch. Okay, but this virtual LANs are controlled again by software inside the switch. So same concept here, except that this is done between the subnets or the networks. So networks can be isolated. So each network for me is a broadcast domain. A broadcast domain. So here I'm using switches. As long as the packet is sent over one subnet, this means that any node can listen to it, because this LAN is a broadcast domain. Okay? So once I send a packet over one subnet, this means that خلاص, this is one broadcast domain, everybody can listen to it. And this is the danger, as he said, that if one node here is compromised, okay, خلاص, I don't have any isolation, so all the network can easily be attacked. But if I have a router, I can have control, so I can isolate the networks from each other. In addition, of course,
usually when I was studying for something, the OSP certificate, I used to see that in real world for the subnets, they have different firewalls. Like for this subnet, it has some different firewalls than this one. Like each subnet have firewall.
لا قصدك firewall rule.
Physical firewall, virtual firewall, even in rule.
Yeah. So you يعني a firewall نفسه has rules. Rules in the firewalls can constrain some communications within the specific subnet, and this is facilitated by routers. Routers facilitate that isolation. If you have a switch, يعني I'm not aware that the firewall can restrict the communication on the level of the physical address. It cannot, because unless you're talking about third layer switch. في layer 3 switch. Okay, but layer 3 switch is technically like a router. هو راوتر بس راوتر ايوه بالظبط راوتر ديسكايز راوتر كده بس متنكر يعني. Yeah, okay. Yeah, okay, so the idea of the subnets is just to provide that isolation between the networks. So this actually enhances the performance, as I said, of course. Because if I have one broadcast domain, every time I send a packet, everyone can listen to it. So your data link layer is always busy with nothing. Yani it's always busy trying to read packets, and then you realize that this packet is not for me, so drop it. Read packet, it's not for me, drop it. Read packet, it's not for me, drop it. So your data link layer is busy with waste of time, right? But isolating this broadcast domain enhances the performance, of course, and isolates the network. Okay. Type. So this requires the fact that we need to have careful design of the IP, and of course in Network 1 we have talked about a significant part of the course was how to design these subnets and how to of course the classless inter-domain routing is a standard protocol that came to the internet. I can't remember the exact date, but the early days of the internet were classful, where the IP addresses are classful, which means that you can conclude what this address belongs to just by looking at the very first byte from the left in the IP address. Okay, so if this byte is from 0 to 128, this means it's class A. If 127, of course, 128 all the way to 191 is class B, and 192 all the way to 223 is class C. And there's class D and E, which are used for multicast, so it's not a big deal. So from this byte, you know exactly, because of course the IP address at the end of the day, the IP address itself has two parts, the network part and the host part, right? Of course, the main focus here is the network part, because that's what I put in the forwarding table. This is based on which I do the forwarding. معنا حسن؟ الكلام متعاد معلش. Okay. طيب in the classful, it was very easy in the early days of the internet, because just looking at this byte, I know exactly what the network part is and what the host part is. So that was good at that time, except that the problem with classful addressing is that it provides really coarse allocation of IP addresses. Coarse allocation معناها the allocation of IP addresses is not fine-grained. Because, you know, like from 0 to 127, how many networks do I have? 128 networks all over the world. Okay? These 128 networks, they have 1 byte for network and the 3 bytes for host. Each network of these, it has 2 to the power 24 hosts. Okay? When you group all of them together, right, you discover the shocking fact that if I model the IP address as a pie that represent the 4 billion addresses for all the 32 bits, okay, you discover the shocking fact that class A contains 128 networks all over the world, and they have 1/2 of the entire IP address. Okay? So that's a huge discrimination. This is a huge discrimination. The class B takes 1/4. Class C, غلبان, takes 1/8. Okay? And class D and E take the other 1/8. Right? So from one class to another, you discover that it's getting tighter and tighter and tighter and tighter, right? So you have 128 networks all over the world, they have half the IPs. Okay? In class B, you have 2 to the power 14 networks all over the world. You have many, many networks all over the world. Okay? These networks, they have 1 over 4 collectively, huh? Collectively, they have 1 over 4 IPs. Okay? For the case of class C, okay, you have 2 to the power, حد فاكر? 21 networks. Okay? Each one of them غلبان قوي عنده ايه 1/8 of the, collectively they have 1/8 of the IPs. يعني معناها as you go from one class to another, the number of networks is much bigger, and collectively all of them they have small amount of IPs. Okay? So later on they discovered that this is a very, very deficient way of allocating IP addresses. The way that they allocated these IP addresses contributed to the fact that we had what we call the IP address explosion, or the IP shortage of IP addresses, okay? Or IP address exhaustion, they call it. IP address exhaustion, okay? So that's a biggie, that was a big problem at the time. So they said, but the good thing about this classical IP addresses is that in the routing table, I don't have to store subnet masks. I don't have to store in the routing table subnet masks, because classical IP address indicates already what is the network part and what is the host part. I don't need to store any extra information. So that was cool at the time, but when we started to have IP address exhaustion, they said, no, we have to do something about it. And then they came up with CIDR, or classless interdomain routing protocol. In this case, we have to store with the IP address, we have to store the subnet mask. So it's not enough to say the IP address is 200. So you have to say slash something. That's in the routing table, not in the packet. Remember, huh? The packet still stores only the destination address, right? Where is this stored? In the routing table, in the forwarding table. In the forwarding table, I have to store the subnet mask, not in the packet. We never talked about subnet mask as part of the protocol data unit of the IP. Did we? Never. We didn't talk about that. So this subnet mask exists only in the forwarding table. Any questions? Type. So this is CIDR, and that actually that was the first step towards solving the problem of IP exhaustion. Because with this, I have the arbitrary level of granularity. I can have خلاص بقى, there's no classes. I can have some network with specific range of IP address, another network with bigger or less. I have complete freedom, and I have the granularity that I need to, to some extent, because IP address exhaustion happened a few decades after this. So this actually delayed the problem. Okay, but nowadays, طبعا احنا even with CIDR is a very old technology for us. So so the next level, okay, of this was ايه بقى؟ احنا what really made IP version 4 survive until now هو النات. Yes, النات and PAT in particular, اللي هو port address translation. Okay. So that was the second level of revolutionary upgrade for IP version 4 that caused IP to survive until now. Okay? And again, that's delaying the problem. That's why they started to talk about IP version 6. خلاص بقى احنا IP version 4 is becoming really dirty يعني. We have discovered lots of issues, and we started to have IP address exhaustion. So we might as well بقى start from scratch and build something that's well cooked يعني. So they started بقى talking about IP version 6. They used all the lessons learned from IP version 4 to design the protocol in the right way, and so on, right? They took into consideration security, because also security was never mentioned as part of IP, and that's why we have IPsec on top of IP to provide security. They said that we might as well do IP version 6 compliant with security aspects as well. Okay. So how does network get subnet part of the IP? So that's what we talked about. It gets allocated through the ISPs, of course. ISPs, they give range of IPs to each client, right? So how many IPs do each of us have at home?
One.
Just one, right? Yeah, so of course, يعني the misconception that each one of us has that each computer at home has a unique IP address, whereas that's not the case. Of course, each one has a unique IP address, private IP address, but of course, our routers, they have NAT and they can map this to the one public IP address. So each one of us has one public IP address from the service provider. But of course, the way that ISPs, they deal with organizations is that, like for example, مثلا Qatar University, they give them a range of IPs, right? But again, that doesn't mean that QU, they are restricted with this number of IPs in terms of the number of computers that they can have in the network. They can have more than that, but in that case, they need to have private networks, okay? And they need to set up NAT in some of the routers to map the private IPs to public IPs. ماشي كده؟ طيب خلاص احنا we can بقى do this hierarchical IP addressing, which refers to the summarization and stuff. We can talk about it next time. You have a question?
After 2 weeks.
Yeah, after 2 weeks. Still talking about the IP, the internet protocol. We talked about IP addressing. We talked about classless interdomain routing protocol. We said that the subnet mask needs to be used together with the IP address, and it needs to be stored in the routing table in order to allow us to perform the packet forwarding. Based on the subnet mask, we perform in the routing table what we call route aggregation, or sometimes they call it route summarization. Many of the routing protocols, they have this route aggregation where they try to save the space inside the routing table by consolidating multiple subnets into one big, network in the routing table. So what will happen is that, let's imagine that we have a service provider, like let's say QU. Inside QU we have subnets like this. We have 8 different subnets, okay? And these 8 different subnets, they have the third byte as 16, 18, 20, and so on, all the way to 30, okay? And all of these, we have طبعا 8 of these subnets, and we have 23/23 as a subnet mask, okay? So what happens is that this service provider needs to distinguish, okay, between these different subnets. So inside that service provider, if you were to send to, for example, an address of 200.23. let's say 16.100, okay? So this packet should be delivered to this particular network, right? So inside the router here, okay, there is a router here. Inside this router, you need to have a routing table that has all these subnets, right? All these subnets and the next hub or the port that the packet should go to. So that makes sense. However, from this ISP to the internet, like for example, Ooredoo, they have their own router here, okay? They don't need to really distinguish between all these different subnets, because all of them, as far as Ooredoo is concerned, is actually connected with this service provider, right? So they don't really need to distinguish between them. So there is a possibility that this service provider can essentially save a lot of space on the routing table by saying that we will summarize or we aggregate all these subnets. Okay, if we take a look at these numbers, okay, these numbers can be consolidated if we were to consider the this address with the subnet mask, in that case 20. Okay, so 16/20, 16 is A, 16 is like this, 0, 0, 0, 0, 1, 0, 0, 0, right? If you take a look at these numbers, okay, we will see that all these numbers, they add some ones here, right? So if I say 16/20, which stops at this point, okay, right? معايا سعيد ولا لا؟ So the first byte is 8, right? The second byte is another 8, so 16. So 20 lies in the middle of the third byte, right? So the middle of the third byte, which includes all these 4 bits, right? So regardless of these 4 bits, regardless of them, right? So the address will be somehow matching the /20, okay? Because /20 needs a match up to bit number 20, right? Anything after 20, I don't care. It will match anyway. So 16, 17, 18, 19, all of them, they match this address, right? Because 16 is 0001, 17 is 0001, بعدين 0001, صح؟ يعني في 1 هنا، صح؟ That's it. صح؟ 18 ليه 01، 19 11. يعني كل اللعب هنا في ال4 bits دي. Okay? If I say 16/20, 16/20 will match, will perform a match if these 4 bits are matching. And these 4 bits, they match already in all these numbers. Okay?
It's like we excluded 16, 18, 20, 30. So we're now finding matches with the 223.
Right.
First of all, internet service provider have its own IP.
Internet service provider?
Have their own IP,
Okay.
such as the radio and internet. Those are divided into 16 and 17 with the same subnet. The organization are a little bit virtual LAN connected to the.
لا، كلمة virtual LAN دي كلمة خطيرة، بلاش تقولها. Okay.
Somehow they are.
هو ال IP addressing allocation is done in a recursive way. What you are saying is correct. The internet service provider, like for example, Ooredoo, they take a range of IP address. They take a range of IP address.
Yes.
Okay? This range of IP address they can allocate in any way they want, right? So they say, okay, so what are our clients? Our clients are, for example, QU. So QU, I will divide this big range of address into smaller range of addresses, okay? Based on the agreement between me and QU, okay? So I will assign to QU this address اللي هو ايه 200.23.16.0/20, right? And then QU will say, okay, inside QU, I can subdivide this big range of IP addresses into 16, 17, 18, whatever, okay? And then by increasing the subnet mask هنا from 20 to 23, I can provide distinction between these subnets, okay? You have a question?
When you say 16, 18.
يا ما انا هقول لك هنا بقى. بص اهو يعني just for simplicity. This is 16. صح؟ Right? Remember, this here is up to here. Here we have 1 byte and we have another byte. So this is 8 bits. 8 bits and this is 4 bits. So 8 and 8, 16. And 4 here, 20, right?
So here we're talking about the third byte.
The third byte, yes. The third byte, right? So 17 is 0001, 0001. 18, 11, or 01, 19, 11, and so on. Okay? So if I say /20, okay, I'm looking for the match in the first 20 bits only. Okay? So it matches. Whether it's 16, 17, 19, whatever. It matches, right? In all cases, it matches. Until you have this 16 plus 15, layer 1, 1, 1, 1, right? Layer 31, right? So up until 31 طبعا احنا ما بناخدش all ones لان all ones مستخدم for broadcast بس ما علينا يعني احنا بنقف لغايه هنا. Okay? Layer 30 يعني. So that's why the last one is 30, right? So all of these they match the subnet mask اللي هو /20, all of them. Right? So this range of IP address is given to QU. QU will say, okay, so I will divide this, okay, into 8 subnets. I will subdivide this into 8 subnets, right? The first subnet will be 16.0/23. معناها بقى ايه؟ ان انا I took another 3 خلينا اعملهم بكلر تاني another 3 here for subnetting. Okay? So this is done by QU, right? So these 3 bits, they will be distinguished between the 16, 18, 19, and so on, right? So each of these subnets now, inside the routing table of QU, they will be separated, isolated from each other, right? This is not what we're talking about, and I'm just trying to explain. So what we're trying to say now is that using the same concept, and since we know from Uridu all the way to QU, we have done subnetting. In terms of routing, on the way back, we do what we call route summarization or route aggregation. بمعنى إن هنا Uridu, they don't really need to distinguish between these subnets. Why? Because regardless of this subnet, I'm going to have to send to QU. صح? So I don't need to have 8 different entries in the routing table of this router. I don't need to do that.
So Uridu is the internet here?
Yes. Okay? So here, I don't need to distinguish between these subnets. Okay? All I need to know is that any packet that matches this big consolidated address, I will send to this service provider. اللي هو بالنسبة لنا QU. QU بقى will take this and then it will have to perform further match which is on the level of 23 بقى. فهياخد هو 3 bits تانيين ويبتدي بقى يستخدم ال 3 bits دول and will distinguish between all these subnets. واضح كده؟ So on the way back in the routing table we perform what we call a route aggregation or route summarization. Both are the same. Okay كده؟ ماشي كده؟ واضحة كده؟ كله تمام؟ طيب. So the question is now يعني بقى غلاسة بقى يعني after I have done all of this, one of the subnets here decided to move to another service provider. Okay? Yani this one, for example, wants to move here. Okay? So the question is, can I perform this movement? Okay? Without violating this route aggregation? Okay?
You can, yes.
And طبعا I can always do that and say, okay, so this subnet will move here and I will have to change the address to match this one. I can do it. لا, that's what I'm saying is, لا, ما تتذكرش عليا. So what I'm saying is, and I want to move with the same address. With the same address. Right? So here, remember that for Uridu, here I have only 2 entries in the routing table. Only 2 entries. I don't need more than that, right? So I will have one route entry to send any packet that matches this address to, let's say, QU. And here, anything that matches this address, I will send it to, let's say, HPQ, right? ماشي كده? Okay, so now I moved one department from here to here. Can I do this? What is the implication of this? If I want to move it and change the address of this subnet to match this, then I don't need to change anything in the routing table of Ooredoo, خالص, right? However, we can still do this movement and maintain the address, okay? But in that case, I have to reflect this change here, okay? So let's verify that this is possible. Take some example that will verify to us that this movement, while maintaining the same address, is in fact possible, okay? And what do I need to do at the router level of Ooredoo in order to make this happen? Okay? This is your question?
I was going to say, what if when you move organization 2 to the other ISP?
Yes.
Let's say organization 2 takes 50 addresses. So what you'll have in this case, a range of 50 addresses in between that are not being used. So do you need to shift everything up?
لا هم لا يعني the same range of IP addresses is maintained for organization 2. Now we want to move organization 2, all of it together here, okay?
Yeah.
And maintain the same address. Maintain the same address.
So there won't be any unused addresses gaps?
No. Of course, if I move this from here to here, yeah, of course I cannot use it here, which means that this router needs to now be updated that this organization is not there anymore. Okay? Which means that in the routing entries here, okay, on this router, I will have 200.23.16.0/23 in the routing table. And I will have 18 I will not have 20.0.20, and I will jump back to 20, let's say 22.23, 24, and so on, all the way to 30.23. But I will not have this organization 2 entry in the router here. Okay? So this will take care of the fact that if a packet goes here, okay, this router should not forward this packet to organization 2 because organization 2 does not belong here anymore, right? What we want to verify is that يعني moving this to here, does it really violate the route aggregation or not? That's what we need to verify here, okay? Because by moving this to here, you have this gap, right? You have this gap in terms of addresses. Obviously, this router is not going to be full because this router, if this organization moves here, this router will remove the entry. So we know this, right? But when it moves here, what will happen back to the Ooredoo router itself, right? Okay. Will this affect the route aggregation of this entry in the routing table? Can we perform this movement smoothly or not?
Obviously, the second ISP RUs is going to have to reflect the change.
Yes, of course. Here, this guy, طبعا, here, the router here, will have to be updated that this entry will be removed from here and will be added to the routing table of this router. So this we know. بس احنا what we يعني this goes without saying. بس احنا what we want to verify is that here we have done some route aggregation. Okay? So this route aggregation, will it be affected by this movement or not? يعني مثلا, will it, can I, if I leave things as they are now, right? Without making any modification in this router at all, I cannot do that because any packet, let's say that has an address of this dot, here we moved 18, so let's say 18.100, okay? And this is /23. طبعا أنا in the packet itself I don't put the subnet mask. Subnet mask is supposed to be in the routing table. ماشي؟ type. This packet now is in this router. This router will obviously match this address with this entry. So it will send it to this port, and this port will go to QU. This QU will say, I don't have this subnet anymore, so this will not work. Okay? So we agree that we need to perform some modification at the router level of Ooredoo. But do we have to change this route aggregation? Do we have to break this مثلا and say لا 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 خلاص, this route aggregation will not work anymore? I have to break it down into 7 different entries in this router, okay? And 7 of these entries will be in this router to go here, and the 8th one will be here, right? In fact, it turns out that all I need to do is just to add this entry in this router table. So I will have so in this router table, let's see. So in this router table map, I will have 3 entries now. I will have 3 entries. Okay? I will have 200.23.16.0/20. Okay? And this will go to, let's say, port 1. Okay? And I will have 191.30.31.0.0/16. And this will go to, let's say, port 2. Okay? And I will have a third entry, which is 200.23.18.0, okay, /23, and this will also go to port 2. Okay? So what we're trying to say here is that this and this do not conflict. Okay? So if I have now an IP address that looks like this, 200.23. let's say مثلا 17 عشان نخليها بس شوية كده. Okay? This will go where? It will go up, right? It will match, this will match this address. صح؟ يعني this is /20. 17.100 matches 16.0/20. واضحة دي ولا؟ أهي 17 is 0001 0001, right? dot 100 ما يهمنيش, مش مشكلة. Okay? If I take the first 20 bits, okay, and make the rest 0, because the subnet mask is A, take the first 20 bits and the rest will be 0 anyway. Okay? If the first 20 bits from the left-hand side, they are identical, then there is a match, right? Obviously here, 0001 and then everything is 0 is in fact 16.0, right? And everything else will be masked. واضح؟ Everything else will be masked. وأنا بس focus على سعيد لأنه واضح ما يعني he did not study subnetting before. واضح. واضح. Okay. Everything else will be masked, which means it will be 0 by default, right? So this is in fact, if I convert this to decimal, this will be 16.0, right? And of course it matches this address, اللي هو 200.23.16.0. It matches, okay? So now I have a match here, right? Obviously, this address will not match this one. It does not match. And here is /23. Okay? It does not match. Okay? طيب. Now بقى, if I send to an address which is 200.23.18.100, okay? And this is the address. This address will in fact match here. صح? And will match here. Will match both. Okay? This is 18, right? It matches this one, obviously, because this is /20. If you take the first 20 bits, okay, it will be 16.0, okay? And it does match here, okay? So we'll have to apply the rule that if you have two matches, then we take the one with the longest subnet mask, which is this one. واضح كده؟ So this entry will be the one that's selected. Okay? So in that case, route aggregation does not really have a restriction in terms of topology change. Okay? We can, in many cases, go around that by adding some entries based on the longest subnet mask in this router table. واضح؟
most of the similar networks will be in the same subnet. And you're taking the advantage of multiple subnetworks
Yes.
in the same.
هو بالضبط هو يعني هو the only cost that we had to pay with this movement that naturally we know that we have to remove the entry of this network from this router and we have to add it to this router. That's that's normal, that's natural. But what changes do we have to add here? That's the question. Okay, and will this change affect the route aggregation or not? It turns out that it's easy. You just need to add a specific entry for this subnet that moved from here to here with the longest subnet mask. Okay? So this way, even if you have multiple matches, which is the case, we have multiple matches here. Both of them, they match. It will still work because automatically for packet forwarding, if you have two matches, you take the one with the longest subnet mask. That's a rule. This is automatic. Okay? So this movement, luckily, did not affect route aggregation. Okay? So we can still, so that's why most of the routing protocols, most of the dynamic routing protocols, which we will study, some of them at least, from an algorithmic point of view, they perform route summarization. They do perform route summarization, and the biggest advantage for route summarization is the saving of space, of course. Okay, so why do I need to put 8 different entries in the router here about these subnet masks? Okay, because all of them, they will have to eventually go to the same service provider. So instead of having 8 different entries in this router, I can have only one consolidated address, right, in this router table, and all of them, they will go here anyway. So this service provider needs to distinguish between these subnets, but this service provider doesn't need to do that. Okay?
For example, like 200 or 23.
ايوه قول انت تختبرني انت اهو قول انت
23
ايوه
19
اوكي
100. Oh, yeah.
So we
Okay.
first compare up to the 23, which is
Yes, هو بص 19 is a is 0001 and 0011
yes,
صح؟
sorry,
اللي هي 16 plus 3
yes.
صح؟ Okay. So 23 is in fact here,
Here.
right? So this, okay, so this will not match this one. This will not match this one, right?
Yes.
It will not match.
So
It will match. It will match, صح؟ تعال نشوف.
But the slash will be different.
0 1 and then 18 is a plus 2 صح يبقى match. Okay, طيب. So in that case, so this address will match here, صح?
Yeah.
And will match here. Right. So in that case, we will send it to here, which means it will go here. And in fact, this address includes this, صح?
Sorry, yes.
Okay? Because here, 18/23 includes 18 and 19. صح ولا لا?
Yes.
Includes 18 and 19. So it matches. ماشي? It works عادي يعني.
Thank you.
Any other questions?
Should it be all of them shift one to the left? يعني internet service provider is Origo and the organization is QU and the internet is internet or?
لا هو الانترنت بالنسبه لنا هي انترنت سيرفيس بروفايدر which is اوريدو اور فودافون يعني حاجه زي كده. Again يعني هو different levels, different hierarchy. You can perceive it in any way you see appropriate. I'm trying to make it simpler and say the internet بالنسبة لنا is أريدو بينما هنا this is مثلا QU. So you can put any hierarchy that you can. Okay. تفضل.
Can you please give us a number of IP?
So this took longer than expected. تفضل. لا تفضل ما تفضل يعني visualize. Type. So this actually finishes or concludes the IP version 4 addressing. ICMP or Internet Control Messaging Protocol is easy طبعا. I will not go through it. It's used for sending control messages for troubleshooting. And the most common two examples for ICMP اللي هم ايه؟ ping و trace route. Right? So I will not go through this يعني we don't have to discuss the details بتاعت so for ping يعني what I normally do is that the ICMP version 4 because we have version 6 of course. ICMP version 4 supports two types of messages mainly. Okay? اللي هما echo request and echo reply. ماشي اللي هو this is echo reply اللي هو type 0 و echo request اللي هو type 8. Okay? All the other messages are in the result in the error reporting. Okay? So echo reply means that everything is fine. This is the happy path. Everything else is an error for error reporting. Error reporting ليه levels بقى. There is network unreachable, host unreachable, port unreachable, protocol unreachable. في details كثيرة يعني في الموضوع. مش هنتكلم على details دي الحقيقة. We don't have time to talk about all of this, and we already discussed it before. بس طبعا more importantly يعني البينج طبعا بيستخدم في ايه؟ If you want to make sure that or if you want to troubleshoot that you can go to the internet. What you do is that you ping مثلا google.com and see if you can get some reply. If you can get some reply, this means that you have some communication to the internet. Or ping أريد. So, but we need to distinguish between pinging a host and pinging a network. Ping a network معناها ping ايه؟ ping الراوتر ايه؟ router port address. Okay, so you can ping a network, okay, by pinging اللي هو بنسميه default gateway address, right? Or ping a host. If I know the host address, I can ping the host directly. Type. This is ping. Trace route.
More detail.
It's more detailed. It gives you the probable route. It doesn't give you only the fact that the ultimate server or the ultimate host is there. It gives you the probable route how to reach there. Yani if you want to go to China, first you have to go to Ooredoo, and then from Ooredoo to somewhere مثلا in Europe. From Europe you have to go somewhere in the States, and from the States, اللي هو ايه? What path you will likely get? Why I say likely?
It's not guaranteed.
Because it's not guaranteed. Because IP never guarantees anything, right? IP does not guarantee anything. You send one packet, it may go to this path. Send another packet, it may go to another path, right? So there's no guarantee that it will go through the same route. But this is the probable one. واضح كده؟ So this is called the trace route command. The trace route command, this TTL expired. Okay? TTL expired, so it will send you a 11 and a code of 0 to indicate that TTL expired. TTL expired. So if you want to ping, if you want to do trace route, what you do is that you send a segment to a destination with TTL equal 1. So what happens is that, so from the host here, you send a message, ICMP message, with TTL equal 1. TTL قلنا اللي هو ايه؟ اللي هو time to live. If TTL equals 1, it will go to this router. This router will decrement TTL. It will make it 0. So this router will send error report with an error called a time exceeded. اللي هو هنا ايه؟ معناها everything is working as designed, because this router will report you the error reporting and where the report is coming from. So you know the IP address of this port, you know where it's coming from, and so you know that the first hub is going to be this IP address which exists in مثلا مساعد. Okay? Then what you do is that you send another message. So this is step number one. Step number two, you will send the same message, but this time with TTL equal 2, which means that it will go through the first router and it will stop at the second router, and here TTL will be 0, right? So it will send you back an error. So you know that, okay, so this is the IP address where the packet came from. So you will report that and you will keep doing this, okay? And you'll keep doing this until you get an error message that's not a TTL expired, okay? Then you know that you have reached the ultimate destination, okay? If you get any error message other than TTL expired, this means that خلاص إن أنت you have reached the ultimate destination, so you stop at this point. So the stopping criteria here would be when the destination returns an ICMP of port unreached. Anything that's not TTL expired for us is a stopping criteria. Okay? Typically, this will be a port unreached. Port unreachable معناها the application that is supposed to respond back to your ICMP message is not running. Okay? But this indicates that an application who runs فين application. My application runs at the host. Okay? So this is an indication to you that you have reached the host. Okay? Once you reach the host, you stop. Okay? So that's typically what happens during the trace route. We study that, so I'm going very fast through ICMP because it's covered in other courses. IPv6 بقى يعني is an interesting topic, although it's covered already in Network 1, especially now. But IP version 6 طبعا it came with the motivation that we have an IP address exhaustion. The address space, IP version 4 address space, is really exhausted, right? And despite the fact that we have come up with CIDR and we have to store the subnet mask in the routing table together with the address, and that saved طبعا some address allocation compared to the first iteration or first edition of IP was classful IP address, right? That was quite coarse to introduce CIDR. So CIDR really saved IP version 4 core for quite some time, right? And then that was not enough, so we had to introduce NAT. Okay, NAT violated the uniqueness of IP address completely, right? But we had to do this, so we had to come up with a surgical solutions. So we defined the concept of private IP, which is reusable across networks. All of us at home, we use the same range of IP, right? All our house networks, they use the same range of IP. So even though NAT violated clearly the layered stack and it violated the uniqueness of IP address, but it was a revolutionary solution and it kept IP surviving until today, and it possibly will keep it surviving maybe for another 10 years from now. Okay? But eventually, we are delaying the problem, right? So some people decided to face that problem, and they came up with IP version 6. But the biggest challenge, طبعا, for IP version 6 is that, okay, so it's not as easy as a simple extension to IP version 4. They found that they have to change fundamentally the protocol data unit. The format, the structure of the header is completely, it has to be changed. Okay? So it's not as easy as ان احنا مثلا we thought in the beginning we used the options fields. فاكرين options field الغلبان ده. We thought that okay, so maybe this can be used for future extension. طبعا it was a short-sighted يعني way of designing the protocol, right? But when they looked at IP version 6, they found that no, we have to do some drastic change. It's not going to be as simple as some changes in the IP v4 header. So we have to come up with completely different addressing scheme, and we have to redesign the header. So they said, okay, so since we're going to have to do that anyway, let's do it based on lessons learned from IP version 4. So not only do we make some changes to the address by extending the address from 32 bits, okay, which gives you around 4 billion IP addresses, and we were really, very proud about it, and we thought that this will be forever, but then it ran out sooner than we expected. So they said, okay, so let's make it drastic. So we changed from 32 bits to 128 bits. 128 bits. Okay? So really, this big exchange changed fundamentally everything. Because even the dot decimal notation is not even feasible anymore. So they came up with the hexadecimal notation. So IP address version 6 uses hexadecimal notation in order to abbreviate the IP address a little. What we really need to discuss here is the motivation behind IP version 6, of course, was the address space, right? But this was not the only thing. This was not the only thing. So since they are going to redesign IP, okay, header, so they thought, okay, so we might as well redesign it in an efficient way. So we know, for example, that IP version 4, it's supposed to use quality of service through the field اللي هو differentiated services code point. Nobody uses it. Okay? So let's provide more quality of service, more systematic quality of service support. Let's try to simplify the header, because the header will have to get bigger anyway because of the IP address, the big IP address space, right? So the header is going to be very big. So let's try to see which of the fields in IP version 4 that was not really used or was not really making a big difference. Remove that, simplify the header as much as we can. And let's see if we مثلا checksum. Do we need to really do some error checking? They found that experimentally the possibility of having a corrupted packet inside the core network is almost zero, right? Inside the core network is almost zero. So they said, why do we need to exchange checksum? Why do we need to perform error checking, okay, on the packet? So this will delay the packet processing anyway. So they decided to remove a lot of things. They decided to remove fragmentation altogether. So remember, we talked about fragmentation?
Yeah.
There are 3 fields: the identifier, the flag, and the fragment offset, and so on, which were part of IP version 4. All of this have been removed completely. Okay? So they said that let's start clean and try to remove anything that's not needed, and try to even name fields like مثلا TTL. We called it time to live. Is it really time to live? It's not time. It's not a timestamp, okay? So they removed it, and they renamed it to hop count, which really is descriptive. It is really the hop count, so we might as well call it that. So they tried to really redesign IP version 6 based on lessons learned. So one thing is that the IP version 4, the header length was variable, right? So we used to have a header length field, right? And what is the reason for IP header to have variable size? What was the reason? الoptions fields. لأن what's variable inside the IP header? هو options fields there. Okay? Why do we need it? We put it there, we never used it. Okay? And we keep exchanging header size, header size, header size. Okay? So 99.9999% the header size is fixed because we don't have option spheres. However, we have to exchange header size every time. Header size every time. Why do we need to do this? Let's just remove the option spheres altogether and you make the header size officially fixed. Okay? So the header size here is officially fixed. But I cannot fix it to 20 bytes like IP version 4, so I fixed to 40 bytes because, of course, of the bigger address. We have to go from 32 to 128. So here I have fixed header size, no fragmentation, no checksum. Okay? All of this, no options. No options fields. Okay? All of this has been removed. Okay? You can see here, the header has become a lot cleaner. It's cleaner, right? So I have the priority, which is similar, but here I have another very interesting field that has been introduced only in IP version 6. And this, together with this, okay, provides quality of service. Is used for quality of service. Okay? Like, what is the difference? The priority provides priority in the packet, right? Regardless of where the packet is coming from and where the packet is going to. صح? It doesn't matter where the packet is coming from and where the... So, the priority of the incoming packet can be scheduled in the route. So, they said, okay, so we can provide quality of service based not only on the host address, okay? لا, based on a flow. Flow معناها إيه? If you have a host, okay, this host runs multiple flows. Yeah, حتى each session can essentially include multiple streams. يعني the stream or the flow is on the level of, if you have a web page, this web page contains video, contains audio, contains graphics. Each of these is actually a separate flow. Okay? And the video might come from مثلا a video server from مثلا Google, but the graphics it comes from another server, or the audio maybe is encoded through another whatever. Okay? So each of these is actually a flow. Okay? So an application might actually use inside it multiple flows, even one single application, right? So they said that the flow label can in fact identify a specific flow, okay, which is part of an application that actually يعني it might refer to a TCP session end to end. Okay? Or actually part of a TCP connection. طيب. This is dangerous. I was expecting someone to say.
So we can say that this flow label is meant for upper layer because isn't.
Yes, it's meant for application level. Yeah, it's meant to provide quality of service. Okay, at the flow level. A flow level which is يعني multiple flows can be instantiated from one single application. Each flow can use a separate TCP session or multiple flows can use one TCP session. It doesn't matter. A flow بالنسبة لي معناها إيه? It's a sequence of packets that have the same treatment. That have the same type of traffic and it can be treated or it has to be treated the same way.
Who decides what the label is?
L'application. ايه؟ انت قصدك لا طب ما هو هنا البرايورتي is decided by the application.
I think the issue might be synchronization between different services.
لا synchronization is done at the application level. I don't know. ايه؟ لا this is controlled by the router على فكرة. Just the fact that you give me a flow label again is not يعني a guarantee. The router may perform the quality of service in a controlled way. I never provide priority based scheduling, never. never. لازم proportional fairness. لازم يكون في proportional fairness. I never schedule high priority packets before low priority packets and give no bandwidth or no resources to low priority flows. I never do that. Okay? And I was expecting another question actually. ايوه اتفضل عبد الله. ايه؟
مش مقتنع بالاي بي فيرجن 6 اطلاقا.
في مش مقتنع فيه.
لا بعد كل العمل الخيالي اللي صار والتطورات وبعدين يعني there's no one have a strong gut to force them to like deal with it. يعني الى الان ما حد مطبق معاه. كلنا في الفيرجن فوق.
لا ما انا هقول لك ايه السبب. بس انا was expecting another question actually. I'm expecting يعني a question like isn't this a regression or going back to virtual circuit? Doesn't this look to you like it's similar to virtual circuit idea?
This is why I'm saying it.
لا it doesn't. It doesn't. And I'm asking the question on your behalf in order to clarify this point. Why is this not similar to virtual circuit paradigm or virtual circuit architecture?
It's not allocating some specific resources for this. It's the dynamic that can change from one package to another package. But the circuit switching, no. You have that amount, it stays to the
Right.
whether you used it or not.
هو صح, what you are saying is true, but more fundamentally than this, virtual circuit number is used for routing. Is used for actually routing, which means that I have to establish a virtual circuit before I start communication. Based on the virtual circuit number, I can actually forward the packet that belongs to this virtual circuit in a specific path, and this path is guaranteed. All the resources assigned to this is guaranteed, and everything is guaranteed before you start communication, right?
Yes.
That's different. Flow label is not to be used for routing. It's only for quality of service. Okay? So this is in a way similar to فكرة TCP and UDP يعني بس طبعا with the difference يعني. هو TCP provides يعني everything is guaranteed, reliability and everything, and it's one package, take it or leave it, right? And we proved that TCP is not always good for all applications, right? And even though UDP does not provide anything, but it might sound attractive to some applications. However, these applications, they try to augment UDP with some extra layer of flow control, congestion control, and, right? Right? Without يعني إيه, taking all the package of TCP. So somewhere in between. This is exactly similar. We don't want virtual circuit because it's not scalable. Why? Because the virtual circuit uses the virtual circuit number for routing, which means that the virtual circuit number is stored in the routing table. It is stored in the routing table, right? The state about the virtual circuit is actually stored in the router. Okay? That really jeopardizes the scalability, right? Flow label is not used for routing. It's not a state. It's not a state. It's only used for quality of service provisioning. Okay? Similar to the priority. Okay? But now, this priority is for the entire IP address, which means that for this host, مثلا, for this host IP. لا, I want to provide quality of service on the level of a flow, specific flow. So video is different from audio, is different from kaza, different. Okay? So providing the quality of service on the level of, and by the way, not only for quality of service, it's used even for security command. Flow label can be used to provide different levels of security on the level of a flow. Okay? So, but it's not used for route, it's not stored in the routing table. So having the flow label does not affect the scalability. It's very important. ماشي كده؟
So الفيلد اللي انا مش مقتنع فيها هو is the version field. Why do we have version field? In IPv4 they had the version field and they only wrote IPv4 in it. Nothing
Yeah.
But now you have version 4 and 6.
لا هو صح, هو الفكرة يعني if you have, يعني هو احنا the problem is that we did not go from 4 to 4.1 to 4.2 to 4.3. احنا went from 4 to 6. But that doesn't mean that when we go to 6 we don't discover يعني any مثلا ايه protocol patches. Okay, then we go to مثلا 6.1 or 6.2. Okay, in that case this version field will be very important, because if I come up with 6.2, I will try to be backward compatible. But it's important to communicate the version field, because if you understand 6.2 and I understand 6.2, then there are extra features in 6.2 that's not in 6.0, right? So if I tell you I'm 6.2, this means that I understand all these extra features. So we can use these extra features to provide more service or better service. But if I tell you, no, I'm 6.0, you will downgrade yourself and you will not use the extra features, which you can otherwise use, but you cannot use it because I'm telling you that I do not understand. So it's for that purpose. However, for IP version 4, it did not happen, and we had to jump from 4 to 6, so that's why it did not help. But they said just the fact that it didn't help for the case of IP version 4 doesn't mean that this will be the case all the time. واضح؟ So other than this طبعا هنا كان في اللي هو ال header length. We removed it because the header is fixed now. It's very neat. We don't have options fields. We don't have anything variable. But I still need to have the payload length because the data part is variable. The data is variable, but the header itself is not variable. ماشي؟
Professor, the source address, these are 128, but then at the bottom I see 32 bits. I know this is a diagram.
أيوة, this 32 bits اللي هي 4 byte word. اللي هو row. Each row. So here I'm expecting to have 4 rows. Okay? Each row is 32 bits. So 32 times 4 is 128. ماشي كده? So this is supposed to be like this. ماشي? So the payload length, and the next header is in fact the protocol field in IP version 4. So they renamed it for a purpose that we'll talk about in a minute. And as I said, TTL has been renamed to hop count. And other than this, خلاص, ما فيش, as you can see, no fragment offset, no identifier, no flag, no checksum, no options. All of these have been removed.
If they remove the fragmentation, then they must have enforced
That's okay. I'm happy with this question. So that's a very good question. So how can we remove fragmentation? يعني
the minimum network.
fragment. افرض أنا I'm sending a packet now on version 6, and all of a sudden I went through a network, and this network has a maximum transmission unit less than what the packet length is. What do I have to do? فقال لك IP version 6 they do implicit fragmentation. بس هم اللي بيعملوا ايه بقى؟ At the source, before the source sends the packet, it tries to estimate, okay, what is the maximum transmission unit on the packet. It tries to guess this, okay, using a technique that we don't have to go through, right? طيب, estimate معناها there is a possibility of error. صح? Okay. So قال لك خلاص, okay. In ICMP version 6, okay, they said that we will add a small functionality كده, that estimation might have some probability of error. So if it happens that you send an IP version 6 packet, and this packet goes through a pass, and it happens that the next network has a maximum transmission unit less than the packet size, we will send an error report similar بقى للerror report بتاع البينج والكلام ده. Packet too big. Packet too big. Okay, we'll see that error in a minute. ماشي كده؟ But they removed it from the header completely. So it implicitly. Okay. طيب اهي packet too big. طيب طبعا IP version 6 comes with a whole protocol suite. Okay, IP version 6, when they went to IP version 6, they found out that everything else has to change. So ICMP has to change to version 6, right? All the dynamic routing protocols, they have to change because the routing table format will have to change.
Yes.
Now the routing table has to store IPv6, right? So, so all the protocol suite of IP version 6, it has to change. So there is a whole protocol stack in IP version 6 that has to be redesigned, including including DHCP. DHCP is an application level protocol. طب انت هتقول لي DHCP ماله دعوة يعني. What this has to do with IP version 6? It does, because DHCP is used to allocate dynamically the IP address. What type of IP address? Version 4 or version 6? The allocation of both types of IP address is different. So DHCP has to have version 6. DCP اللي هو اسمه ايه؟ Domain Name Service اللي هو DNS. DNS also has to change. Right? So there is a whole ripple effect that comes with IP version 6, and that's why Abdullah is not convinced with it. And this is the main reason until today that we cannot really say that we are version 6 compliant or version 6 friendly. Okay? But we will get there. We will have to. We have no other choice. Okay? This is what we need to talk about. So the transition from IPv4 to IPv6, okay, it cannot happen overnight. Doing the transition overnight معناها ان I have to shut down the internet. Okay? And I tell everyone, okay, so stay at home, so we'll upgrade all the routers to version 6, and next morning everything. But of course, we cannot do that. There are tens of millions of routers and network resources that have to be upgraded. We cannot do that, right? So the designers for IPv6, they thought also about a transition strategy, a strategy for transitioning from IPv4 to IPv6. And the idea, because of the hierarchical and the distributed nature of the internet, they have to come up with a strategy that allows for gradual deployment. Okay? So we will have to live, okay, for years with parts of the internet as IP version 4 and other parts are version 6. We will have to do that. But now, what techniques need to be there in order to allow for this coexistence of IP version 4 and IP version 6 together at the same time? Okay? So they came up with the concept of tunneling, and tunneling has two steps. First, a node can have the two stacks اللي هو IPv4 stack, and this IPv4 includes ICMP, RIP, OSPF, DHCP, DNS, all of this. All of this has to go with IP version 4, okay? And the same node may in fact have IPv6, okay? And this comes with ICMP and NAT, by the way, come in. And ICMP v6, RIP v6, everything. And NAT is called NAT 64. Okay? So one single node may have both stacks. We can do that. It's software. Okay? It is software, right? So one node may have both stacks. Type. What will be the benefit of this? This node, this same node, can be now part of a network which is IPv4 network, or another network which is IPv6 network. Okay? Even if both of these networks they coexist geographically, this node may select at any point of time to be part of this or part of this. معناها يعني Windows version 10, okay, Windows 10, it has both stacks. Okay, so يعني if you have Windows خلاص يعني أنت you are you have the choice to be part of a version 6 or version 4. That's easy. Okay, but you will not necessarily be able to provide intercommunication between the two networks. So dual stack does not really give you the ability to provide communication across two different networks. So if you want to provide communication from V6 to V4, then you have to provide some transformation from one stack to another. Okay? So you have to do that using a certain technique. So this technique is called the tunneling. So dual stack itself is not enough. So you have to have tunneling. Dual stack is given. We can use Windows and we have dual stack. But we need tunneling. So the idea of tunneling is this. We will have this dual stack, and then it will go from IPv6 to IPv4. It will perform this migration. I don't want to call it translation. Okay? It will migrate itself to IPv4, and then from IPv4 it will go back down all the way. And then at E, the destination of the tunnel, we will have to go back from 4 to 6 and then go up.
Regarding that hub B, it knows by port number that the next hub is not supporting version 6.
A port number.
How does it know the next hub is not supporting version?
ما هو So typically IPv6, if I deploy IPv6 at the core network, okay, then any network at the edge that tries to talk with the core, it has to be IPv6 compliant, right? Okay? So it's not advisable whatsoever, okay, to make the core network IPv6. Okay? Because all the other networks or the other service providers are dependent on the core, right? So the more typical scenario is that we deploy IP version 6 at the edge. Okay? So you may have IPv6 at the edge because the edge has nothing dependent on it. واضح? So it's easy to deploy IPv6 locally inside the edge. Okay? So here you have an edge that's IPv6, and here you have an edge that's IPv6. But the core network is still IPv4. Right? Why? Because the many people, you are not the only edge that's connected to the core. So you have many other networks that are connected to the core. Okay? Everyone should understand IPv4, but not everyone will have Windows 10. Not everyone will have dual stack and tunneling. Not everyone will have this. Okay? So I have to keep the core network IPv4. Okay? So then to provide this this transformation, this is what we call a tunneling. So tunneling is easy. Tunneling معناها ايه؟ ان احنا عندنا IPv6 header, and we will at the network layer, here at the network layer, طبعا النتورك لاير بتاخد من ايه؟ من الترانسبورت لاير، بتاخد مثلا TCP ولا حاجه. Okay? So at each layer we perform what we call encapsulation, right? So we take the segment, okay? We add the IP header to it, right? And then we send it down. لا tunneling قال لك بقى لا, before you send it down you have to perform another encapsulation, okay, at the same layer. Okay, so you have to perform another encapsulation. So this will be IPv6 طبعا. Okay, so re-encapsulate IPv6 inside IPv4 header. So for us, IPv6 packet has become like a TCP segment. Okay? It's totally seamless. It's transparent to us. We don't know what's inside. مالناش دعوة. Okay? So this will allow you to go smoothly through IPv4. Okay? But you have to come here and perform the reverse operation if you want to. So you have to create a tunnel from here to here. The same idea, by the way, is used for IPsec. لو IPsec ما بيستخدم tunneling اللي IP security. Okay? يعني this idea of tunneling is used in many يعني disciplines and fields, by the way, right? ماشي كده؟
I think they have finally found the use for the options field in this tunneling.
لا هو tunneling they found that they didn't use the options fields for this. No.
They encapsulate the whole IPv6 packet.
Yes.
Inside the data part of the IPv4.
هو الفكرة في إيه؟ هو الفكرة إن أنت when you do this encapsulation, there is a very important flag here which points to the protocol. Okay, in the upper layer, صح؟ مش في هنا بروتوكول بيبوينت to the upper layer؟ المفروض البروتوكول فيلد ده يبوينت to ايه؟ TCP. لا هيبوينت ل IPv6. Okay, بس. This protocol will point to IPv6, which means that in the decapsulation, instead of going to the TCP process in the transport layer, it will go to the IPv6 process in the same layer. Okay, that's it. So IPv6 will process this and then will send it to TCP. So it's another decapsulation step inside the same layer. Okay, so that's basically the idea of yes. ما هو B is the node that has the dual stack. Okay, so in that case, tunneling. So that's how it looks like. So we'll take the source A and F, which is this source, and this is the destination, right? And as we all know, the source and the destination in the packet, it does not change. It's kept in the packet, and it's not supposed to change unless we're using NAT. We're not using NAT. So the sources A and F, which are IPv6 addresses. Right? So here we will do another level of encapsulation, and here the source will be B and the destination will be E. So B and E. E هنا it will do the reverse operation of the tunnel. The reverse operation of the extra encapsulation step. واضح كده؟ So that's it. So this with this simple idea, they were able to provide اللي هو ايه الجرادوال deployment. طبعا they have come up with another method which is ايه بقى يا عبد الله؟ بلاش انت عشان مش عاجبك There is another method other than tunneling which we studied in network 1. ها؟ اللي هو converge اللي هو صح اللي هو اسمه IP translation. Okay? So instead of performing another encapsulation step, لا احنا هناخد الهيدر نفسه ده. Okay? We will not do another encapsulation because this encapsulation and tunneling, by the way, it's very clean. يعني it's very clean and seamless. لا احنا what we will do بقى in that case, we will translate that to IP version 4. يعني كده we'll take the address and map it. We will take the DHCP and map it. We will take every single field in the header of IPv6 and map it to IPv4. ممكن بقى في الحالة دي بقى لا بس هيدي بقى صح. يعني ممكن مثلا نعمل ايه؟ نقول طبعا ايه؟ طب هنعمل ايه في الفلو ليبل؟ الفلو ليبل ملوش خلاص ارزعه في الاوبشنز يعني وديه كده في الاوبشنز ولا حط في اي حته. يعني حاجه زي كده. بس in order to do this we have to provide a mapping mechanism, a translation mechanism. So we have to have a mapping table which is different from the routing. يعني قصة كده يعني. مش you don't have to go through it. بس احنا يعني what we need to know is tunneling. tunneling is very clean and neat, and it works seamlessly. It doesn't have to introduce any complexity.
But this is happening it's already encapsulation.
Right.
Encapsulation is implemented with the stack itself. Yeah. So it's being done by hub B.
هنا, it's based on this source and this destination. So this is the beginning of the tunnel and this is the end of the tunnel. This is the one that will perform the extra encapsulation step, and this is the one that will perform the extra decapsulation step. ماشي كده؟ واضح؟ Any other questions? تمام؟ طبعا لو انت عندك مثلا هنا IPv6 and then the rest is IPv4, then خلاص يبقى ال ultimate destination هو خلاص هو الهوست خلاص. You don't have to the end of the tunnel is the host itself. ماشي؟ طيب احنا هنقف هنا ونبتدي